In the previous video, we have already explored the process of creating a library and cell view for our project. If you haven't yet watched part 1 of this series, you may click on the I button at the top of your screen. In that video, I have already discussed some fundamental concepts regarding the functionalities of the schematic window. Today, we will work with small component in the schematic and truly understand every aspects of the schematic window. As you can see, this is the schematic window. Now, we need to place an instance. You can do so by clicking on the instance icon. Alternatively, another method to place an instance is to first press the escape key on your keyboard to cancel any ongoing action and then press the I key. This will open the same instance window. Now, let us place an instance. When you open the instance menu, you will see the library section. Since I am using a CLPDK, I will select the CL library in my case to access components such as transistors, resistors, and capacitors. In this section, we need to select the desired cell from the library. As you can see, there are multiple cells listed here. For example, I am going to select NMOS_18 from this list. Here, you can see the various parameters associated with this cell. In my case, the NMOS_18 parameters are displayed. We have the flexibility to modify these parameters according to our requirements. Let us experiment with some of these options to gain a better understanding of their functionalities. For example, if we modify the add wire stubs at all terminal option, you will notice that all the terminals of this transistor are automatically connected with wire stubs. Now, let us explore the functionality of the array option, particularly the rows and the column settings. If we change the columns value from 1 to 5 and place the transistor in schematic, you will see that a total of 5 transistors are automatically created in the same column, allowing for easy placement. Next, select all the transistors by dragging over them from the top and delete them from now. Now, let us observe how the rows setting functions. If we change the rows values to 5, you will notice the same effect, but this time the transistors are arranged in a row instead of a column. This feature allows us to efficiently create a large and complex circuits or array with ease. Before placing the transistor on the schematic window, you can easily rotate it in any direction by clicking the rotate button repeatedly. You can also flip it sideways or upside down according to your requirements. However, please remember that this modification must be made before placing the transistor in the schematic. In this section, you can see that we have the option to modify various parameters of the transistor before placing it in the schematic. These includes total gate width, gate length, fingers, multipliers, and modes. Now, let us understand what these parameters represent and how they affect the transistor. You may apply a threshold if desired. The multiplier has already been discussed. Additionally, you have the option to connect gates at the top, bottom, or both. Furthermore, there are options to set the minimum width of the end cap, the minimum spacing between poly and diffusion, drain contact coverage, and source contact coverage. You can also switch the source and drain directly from this section. Moreover, several additional options are available for this NMOS transistor. So, you need to hide this window to place the transistors within the schematic. To place it, simply click inside the schematic. As you can see, I have placed on transistors, but it remains selected. To exit any ongoing action, such as this selection process, you can press the escape button on your keyboard. So, if I zoom in on the transistor, you will notice that all its parameters are clearly displayed, including width, length, fingers, and multipliers. When selecting the transistor, The property editor window became highlighted at the bottom left corner of the screen. As the name suggests, this window allows users to modify the transistor properties. All relevant parameters are listed here, and if needed, they can be edited directly. For example, I can change the width from 0.42 to 0.84 within this window. As you can see, the update is applied instantly both within the window and in the schematic itself. The same action can also be performed by pressing the Q key on the keyboard after selecting the component from the schematic. This will open the object properties window where all the parameters are listed. Additionally, this window includes a display option. For example, if I set the display of the total gate width to value and click apply, the value I previously set 0.84 in this case will be highlighted in the schematic. Similarly, if I change it to both and apply these changes, you will see W is equal to 0.84 displayed. However, to view it properly, I may need to zoom out. Now, as you can see, the value is clearly visible. Let us proceed by changing the display setting back to off and applying the changes. Now, if you wish to apply a voltage, you will need to take a new instance. To do this, change the library to analog leaf. Inside this library, you will find a list of available symbols. For example, if we select VDD, you will see a corresponding symbol appear. The parameters of this component can be edited later from the stimuli section when performing a simulation. However, for now, we will use VDC so that we can directly modify its parameters. After selecting the component, you will notice the DC voltage option listed. For instance, I will set it to 1.8 volt for now. However, it is important to be careful here. When entering the value, you must not write 1.8 followed by the unit V together. If you do so, the simulator will consider the V as a variable, leading to an error. The default unit is volts, so you only need to specify if using nanovolts or millivolts depending on the required value. After that, we can place the VDC component in the schematic. As you can see, the VDC symbol remains selected, allowing you to place it multiple times if needed. If you wish to delete a component, you can select the delete icon and click on the component, which will remove it directly from the schematic. Alternatively, you can drag and select multiple components, then press the delete key on your keyboard to remove all the selected items at once. Now, I would like to show you an interesting feature, how to copy and paste any object within the schematic. For example, if I need an additional VDC component, I can select the existing one and press C on the keyboard. You will notice that the cursor changes and a plus icon appears, indicating that the tool is ready to copy objects from the schematic. Next, you simply click on the object you wish to copy. As you can see, the VDC component has been copied. Now, to place it in the desired location, click where you want to position it, and it will be placed accordingly. Unlike the instance placement mode, this method allows you to copy and paste the object only once per action. If you press R before placing the copied object, you will notice that it rotates. The orientation changes with each press of the R key, allowing you positioning it any desired direction before placement. So now we need to connect wires. So if I select the wide wires from here, so you can see I am connecting to this node and the wires are very thick. So if I take the narrow wire from here, you can see here similarly I am connecting two components and the wire is looking good compared to the wide wire. So let me delete it first. So I will take the narrow wire. You can click on the icon or you can press W from your keyboard to take the wire and connect the wires between the components. So I'm connecting drain to this VDD, that VDS I am taking here, and I am also connecting the source to body, and I will complete the circuit totally. Now I have to connect on ground here, so I will take the ground from the analog library. So after selecting the analog library from the cell, you can write ground GND, the small GND directly, the ground will come. So after selecting the ground symbol from there, you have to place done the connection. So I want to show you one thing. If I place the ground here, what will happen? If I connect the wires, there will be on warning. So if I just try to check and save the schematic, you can see there is on warning. So let me show you what is the warning first. So if you close the pop-up and if you press G from your keyboard, you can see the warning that you are facing from a circuit. So here it is saying solder dot on cross over at the location. So this is the highlighting point. So if you click zoom to marker, the marker will be zoomed to the location. So let me disconnect the ground from here and I will connect the ground a little bit right side of this design. Okay. So now if I check and save the circuit, there will be no warning. You can see it clearly. So now all the connections are made. At this point, you can easily launch ADEL from here to run the simulation and analyze the behavior of the transistor. However, I would like to demonstrate another useful feature, how to label wires and directly link one object to another. To begin, I will first delete all the existing wires. Next, I will position all the voltage sources on one side for better organization. Now, let me copy the VDC component and place an additional one. The reason for this will become clear shortly. Now, to connect the components, you need to draw wires. To do this, click on starting point of the wire and extend it to the desired endpoint. To finalize the wire connection, you can either double click at the endpoint or press the escape key on your keyboard after a single click at the endpoint. This will properly terminate the wire connection. Similarly, I will connect all the terminals with the wires. So all these steps can indeed be quite time consuming. So let me show you a more efficient way to achieve the same result. First, I will delete all the existing objects from the schematic. Now, when taking an NMOS transistor from the instance menu again, this time I will enable add wires tabs at all terminals. As you can see, the wires are now automatically connected to the respective terminals. Similarly, we will use this method for adding other components as well, making the process much quicker and more convenient. So here I am taking 1.8 volt as DC voltage. Now to place it, click on the schematic window. 3 times I need VDC, that's why I am taking it 3 times. Let me show you another way to do that. To save your more time, then first of all let me delete all this VDC from here and take the instances again, and this time use the array option from here. So if you change the columns from 1 to 3 and take the 1.8 as a DC voltage and hide this pop-up from here, so what you will see, after clicking on time the VDC, 3 times VDC will appear side by side. So while the VDCs are now 1.8 DC volts as leveled, here you can see. To label the wires, you can either click on the create wire name icon or simply press L on your keyboard to achieve the same result. So here I will give some name. For this VDC, I will take VDS from here, and that will be my ground, or you can say the VSS. So I will write here VGS in the name section here. If I hide and if I place the point, you can see the point, no? If I place the point on the wire, then the wire will be leveled. You need to be careful, you need to place the point of the name. And then similarly I am taking the VDS from here, and for the VSS I will take the VSS from here. Okay, so let me show you another way to do that more easily. So let me delete it first and take the level wire name again and write all the you have needed. So here I am taking 2 times VGS because 2 times I need to place. Similarly VDS also I will take 2 times. So there will be VDS and there will also be a VDS I will place. Now instead of GND I will take a VSS. That will be good. So VSS and VSS I will take 2 VSS from here. So now I will hide this window. Now I can place all the names that I have created. First I have created VGS, so let me place it here. VGS, and the transistor, the VGS will be here. So again a VDS will be here and the transistor, the VDS will be here. So now VSS I will connect here. So far it's done, the leveling it's done. So now what I have to do, I have to connect the ground here. So I have to connect all the 3 wires from here. I need to connect on ground here. From where I will take the ground, from analog leaf I will place and again that instance from here, and I will take the ground as cell. So after taking the ground, but here you can see the wire automatically created, so I don't want that. If I don't want that, so I will uncheck the all terminals option from here. So if I click on register terminals only, the wire will not be there. So you have to just click on there very carefully. Okay, so if you just check and save. Now I want to show you another interesting thing. So let me click and press Q from the keyboard so that I can take the instance property or editor. So the edit object properties will pop up. So now from here the DC voltage I will change 1.8 to 0. If I write here 0 and click on apply, the thing will work as ground. I just level the thing. Okay, that is the way to level the ground. So that's it. Now you can see the title bar. The XYZ NMOS schematic is mentioned in the title bar, but here on start is also there. So that means your design is not saved till now. So if you click on launch and if you click on ADE, you might face some difficulties to launch the simulation. So what you have to do, you have to first check and save the result. You can click on save also, that doesn't matter, but yeah, it matters when you have some errors or warning. You have to click on the check and save to verify it. Now you can see the star has been vanished. Now you can easily launch the ADE. Now let us explore the selection filter. If this option is enabled, it allows you to select any component or object within the schematic. Similarly, you can adjust the filter to enable selection for specific element such as instances, wires, ensuring more precise control over your selection. That concludes everything related to the schematic window and circuit creation within it. In the next part, we will explore the ADE analog design environment to simulate this circuit. If you have any doubts or queries, feel free to reach out through the form linked below in the description. You can also contact me via email. Looking forward to see you again in the next part.